So for question 1, it gives us a probability, and k is discrete value, and problem A, it asked us to find out B, so that P is a valid probability mass function. So if P is a valid probability mass function, the sum of all values of P should equals to 1, and therefore we can write this function. We sum this together and it should be equals to 1, and we can find out that the k times p power of k minus 1 it can be written as the form of a derivative, and we can calculate the limitation of p power of k, and it should be this one. And when k is infinity, the p power of k is actually actually 0, because p is from 0 to 1. So the result of this limitation is p over 1 minus p. And we calculate the derivative of this one, and we can get this equation and equals to 1. Then the result is b equals to 1 minus p squared. And for problem B, it asks us to find out the expectation of x, and so the expectation should be k, because x is equals to k, and k times the sum of b times k times p power of k minus 1. And because that the sum of p power of k is 1 over 1 minus p, so we can take the derivative of both sides, and we can get that this equation. And because here we need to get a k squared times p power of k minus 1, so we can do this one again. But firstly, we times p on both sides, and we could get this equation. And we take derivative on both sides. It's very similar to the previous one. So we can get this equation, and we can take this equation into the expectation equation here. So therefore, we can get the expectation of x, which is 1 plus p over 1 minus p. And for question C, it asks us to find out the expectation of x squared, and we take x squared into the equation, we can get this sum of b times k cubed times p k minus 1, and this equation is very similar to the previous problem. So from problem B, we can get this equation using the same approach. And then the final answer of expectation of x squared is 1 plus 4 times p plus p squared, and over 1 minus p squared. And for problem D, we need to find out the expectation of these two values, and these two values we have calculated in the previous two problems. So we just take the values, take the results into the equation, and we can get the final answer, which is 2 times p squared plus 6p plus 2 all over 1 minus p squared. And for problem E, it gives us a p p-value, which is 1/3, and we need to calculate the conditional probability mass function when x is from 2 to 5. So firstly, we need to take the p-value of p into b, and we can get that b is 4/9, and we also take the p-value into the probability, which is 4/9 times k times 1/3 power of k minus 1, and then we calculate the probability when x is from 2 to 5, and we can write this function into this form. And for this part, we need to calculate the sum from that k is from 2 to 5, which is case 2 plus case 3 plus case 4 plus case 5, and finally we can get a result that is 0.5377, and this is a case of k is greater than 2 and smaller than 5, and for other cases, for other k values, the probability should be 0.